If you drop a piece of soap on the floor, is the floor clean or is the soap dirty? Why is it called a building if it is already built? Why do we park in driveways but drive on parkways? And seriously, what would actually happen to the world if a massive, magnitude 10 earthquake suddenly hit? Welcome to Midnight Questions. Today, we are answering, what would happen if a magnitude 10 earthquake hit the Earth? Before we dive in, if you're new to the channel, make sure to subscribe so you don't miss our future late-night explorations. All of these questions just melt away the moment you put your head on your pillow, only to be replaced by dozens of other random, mind-bending thoughts. But let's take that last one seriously and look at the actual physics of the Earth. There seems to be a direct connection between the quiet of nighttime and our brain's tendency to overthink massive, world-ending scenarios. The silence just leaves room for the loudest possible what-ifs. Whenever you hear about an earthquake on the news, they usually mention the Richter scale. But scientists don't actually use the Richter scale for massive quakes because it maxes out around a 5.5. For the big ones, geologists use the moment magnitude scale, and that is the metric we have to use to figure out what a perfect 10 actually means. This chart shows the exponential power multiplier between magnitude levels. Every single step up is roughly 32 times more powerful than the last. So the leap from a 9 to a 10 is an enormous exponential jump in raw energy. The most powerful earthquake ever recorded was a 9.5 in Chile back in 1960. Based on the math, a magnitude 10 would be roughly 16 times more destructive than the worst quake in recorded human history. A magnitude 10 is an extreme mathematical release of energy. Geographically speaking, the only place on Earth with tectonic plates large enough to produce this kind of tension is the Pacific Ocean's Ring of Fire. At the epicenter, the energy released would equal about 15,000 megatons of TNT. That is the mathematical equivalent of detonating 1 million nuclear bombs all at the exact same time. If that epicenter was located just 125 miles away from a major coastal hub, like San Francisco or Seattle, the results would be total. At this level of violence, the concept of earthquake-proof engineering ceases to exist. Without warning, every single structure, skyscraper, and major bridge in the area would instantly collapse downward under the incredibly violent shaking. Simultaneously, the sheer upward force of the shockwaves would literally launch deep-rooted trees and entire wooden houses straight into the air. Within the first 30 seconds, modern human infrastructure within a 100-mile radius of the epicenter would be completely erased. This is a world map showing the outward expansion of the primary shockwave. Mathematically speaking, as these vibrations travel across the globe, there wouldn't be a single square foot on Earth immune to the shaking. Even on the exact opposite side of the planet, the ground would tremble. As the primary wave passes over other continents, the intense vibrations would immediately trigger smaller earthquakes along distant fault lines. This sudden global geological unrest would agitate magma chambers worldwide, initiating massive volcanic eruptions. The primary quake essentially acts as a planetary detonator, turning the Earth's entire crust into a highly active, interconnected weapon against us. But the shaking is only the initial phase. Within minutes, the rapidly displaced ocean would form mega-tsunamis, towering walls of water acting like cosmic bulldozers. These waves would sweep inland, leveling any remaining debris and completely wiping out every major coastal city in the Pacific Ocean. This surge of water would destroy international shipping ports along thousands of miles of coastline, instantly severing the global supply chain. Even for survivors on the opposite side of the globe, the immediate halt of international trade would plunge the world into an economic dark age. Before you lose sleep tonight over that nightmare scenario, let's look at the actual physical constraints of our planet. This is a top-down model showing a tectonic fault line attempting to slide. Structurally, the Earth's tectonic plates simply aren't long enough to generate the amount of continuous friction required for a magnitude 10 earthquake. Because of these physical dimensions, the absolute maximum energy our planet can physically produce is capped at about a 9.8. There is exactly one caveat. We could only see a magnitude 10 if a massive asteroid directly slammed into the Earth. But if a rock that size hits us, a magnitude 10 earthquake is going to be the absolute least of our survival problems. So the very anatomical limits of our planet actively protect us from its most apocalyptic mathematical possibilities. We have a question for you. What is the weirdest question that has ever popped into your head in the middle of the night? Let us know in the comments below so we can answer it in a future video. If you enjoyed this, don't forget to like, share, subscribe, and hit the bell icon. See you next time.